Okay, welcome in. Let's do another example. So here's another example where we've got this function, right? And we want to use this linearization of this function at x equals 0. And then we want to use that linearization to approximate this value. So let's do it. So now, x equal to 0. Yeah. So yeah, let's do that. So let's again start with what we know, right? We start with the linearization. So f of x is approximately equal to f of a plus f prime of a times x minus a. And now, what's f of a? Well, f of a is, when x is 0, this is just 1 to the nth power, right? Which is always 1. Right? It's always 1. So that's going to be approximately equal to 1 plus, now, f prime of a. Well, how do we take f prime of x? Well, f prime of x is equal to what? Well, it's going to be the chain rule, right? So this is going to be n times 1 plus x to the n minus 1, and then times the derivative of the inside, which is just 1. So that's what we get. Okay? Now, if we plug in 0, guess what? If we plug in 0 here, we still get 1 for this part. 1 times n is always going to be n. So this is going to be n times x minus 0, which is this x. So we get approximately 1 plus n times x as our linearization. All right. So now, let's use this to approximate 1.01. So f of 1.01, well, we want to approximate 1.01 cubed. So that means n is 3, right? And so this can be written as 1 plus 0.01 quantity to the cubed to the third power, right? So now, so that would mean this is going to be approximately equal to 1 plus 3 times 1.01. Okay? Or excuse me, I'm sorry. Hold on a second. Right, no. This is, no. Sorry, I was So here, we want it in this form, so that means x is 0.01, now 1.01. So this is x, right? So this here is your x. This is your n. So then 0.01 goes here. Okay, that's correct. Okay? And yeah, and then this becomes 0.03 plus 1, so this is going to be equal or approximately equal to 1.03. Okay. Now, what do we get? Let's put that in our calculator and see what we get. Okay, so we get 1.030301. So 1.030301. So not bad. So it is accurate to do 2 decimal places. Okay. So you see another way that we used the linear approximation. So in this case here, oops. So in this case here, we start with this, but we were given this, so we had to rewrite it, expand it out like this to match it up so we could figure out what x would be to plug into here. Okay? And then we were able to get the right answer. That's it. Have a great day.